Hi there, welcome to this Elkchemist chemistry video in which we're going to look at the calculation known as percentage composition by mass. In this video, we're going to aim to define the term percentage composition by mass and look at a couple of worked examples so you understand how to tackle these calculations in the future. Let's take a look at the definition in front of us now. To do a percentage composition by mass calculation, effectively we'll be taking the relative mass of a particular element as a percentage of the relative mass of the whole compound. What that means is effectively looking at the relative mass of a particular element compared against the relative mass of the entire molecule or compound of interest. Okay, let's try our first worked example. We're going to use the compound iron 3 chloride in this example. That has the formula FeCl3. Imagine we were asked to find out the percentage composition by mass of iron found within iron 3 chloride. That would look like this. We take the relative mass of iron, which would be the mass number from the periodic table for iron, and divided by the relative mass for iron 3 chloride with this formula FeCl3. That would be the relative formula mass of that compound, which I'll show you how to calculate shortly. We then multiply by 100 to convert our value into a percentage. So that calculation would involve us taking 56, which is the mass number of iron, divided by the relative formula mass of iron 3 chloride, which would be 56 plus 35.5 times 3 for the 3 chlorines that make up the formula of iron 3 chloride, multiplied by 100 to convert to a percentage. And if we type that into our calculator, we get 34.46 as our answer, effectively meaning that 34.5% of the mass of the iron 3 chloride is accounted for by the mass of the element iron. Let's look at one more worked example just to be on the safe side. This time imagine we were asked to work out the percentage composition by mass of carbon in the compound ammonium carbonate. Now ammonium carbonate has the formula NH42CO3, and the NH4 is in brackets, meaning there are 2 ammonium ions to every 1 carbonate ion in this compound's formula. So as before, we take the relative mass of carbon in this case, which is the mass number of carbon, divided by the relative mass of the entire ammonium carbonate compound, that's the relative formula mass calculation required there, multiplied by 100 to convert to a percentage. So 12 is the mass number of carbon, and then looking at the formula, we've got N2, 14 times 2 for the 2 nitrogens, 4 hydrogens multiplied by 2, that's 1 times 8 for the 8 hydrogens present in the formula of this compound, 12 for the carbon again, and 16 times 3 for the 3 oxygens in the ammonium carbonate formula. So taking 12 divided by the sum of those values times 100 to convert to percentage gives us 12.5%, meaning in terms of relative mass, 12.5% of the mass of the compound is contributed by the element carbon. There you have it, folks, a nice short calculation video this time. Don't forget, if you found this video useful, please think about giving it a like. You can always subscribe to the channel. You can even ring the bell to get notified of our latest content. We put out videos on a weekly basis. You could even share this video or other videos on the channel with friends studying chemistry to spread the learning of chemistry far and wide, and your support is always hugely appreciated. Thank you so much for listening. Take care. Bye now.